Today we're going to be working on the properties of exponents with division. We just completed multiplication, so along the same lines we're going to be working with exponents. The problem says Lightning Speedway has a race car on a display platform. The expression below can be used to determine the amount of pressure the car is applying to the display platform. Write the expression in expanded form, then simplify to a single base raised to an exponent. So it says pressure equals 10 to the fourth power over 10 squared. So when we expand this out, 10 to the fourth power would be represented by 10 times 10 times 10 times 10. And 10 squared can be represented by 10 times 10. And when I'm looking at this, I see a fraction. And whenever I have a number divided by itself, or a fraction with the same number in the numerator, the top, and the denominator, the bottom, I can cancel because 10 divided by 10 is 1. So two of my 10s from the top cancel with the two 10s on the bottom, and I'm left with 10 times 10, which can be written as 10 squared. Using this example and any previous knowledge of the properties of exponents, make a conjecture about the property of exponents with quotients. What it means is we're making a prediction about how we get from 4 and 2 to 2. And I noticed that we eliminated two 10s, so I would assume 4 minus 2 equals 2. So that is my conjecture. The top exponent minus the bottom exponent is equal to my new simplified exponent. Now, I'm going to test this conjecture by writing an expression in expanded form of each of the following. So I have 2 to the sixth power, which is 2 times 2 times 2 times 2 times 2 times 2. I have 6 of them. And on the denominator, I have 3 2's. And again, 2 divided by 2 is 1. So I can cancel out 3 of the 2's, leaving me with 3 2's. With the x's, I have 5 in the numerator. And I have 1 in the denominator, because anytime we don't have an exponent, it's an exponent of 1. And again, I can cancel x divided by x, no matter what x is worth, it's going to be equal to 1. So I end up with 4 x's. Now we're testing our theory. Is 6 minus 3 equal to 3? Yes. Is 5 minus 1 equal to 4? Yes. So the quotient of powers property, remember quotient means to divide. When I'm dividing two powers with the same base, I can subtract my exponents. We're going to practice this theory, and we have to remember to group like terms, then apply the property when necessary. So I have 6 to the fifth power, which would be 6 times 6 times 6 times 6 times 6. Over 6 squared, which is 6 times 6. And I could cancel, again, two 6's, leaving me with 6 cubed, or 6 to the third power. Testing my quotient of powers property, 6 to the 5 minus 2, taking my exponents and subtracting them, would equal 6 cubed. I'm just going to use the rule on number 2, but I have to remember to separate my coefficients and my ends. So I have 4 divided by 2 regular. I'm not subtracting these exponents because they're just regular numbers. 4 divided by 2 is 2. But then I have n cubed minus 1, because remember, if there isn't an exponent, it's 1. And that would leave me with n squared. So when I simplify, I have 4 divided by 2 is 2, and n cubed minus 1, which is n squared. I'm going to do the same on the next. I have 7 over 14. If you put that in your calculator, you get 1/2. I have x to the 5 minus 2, which is x cubed, and y to the 4 minus 2, which is 2. So this would simplify to 1/2 x cubed y squared. If I want to simplify it further, I can put the x cubed y squared in the numerator, and my 2 stays in the denominator. but I can eliminate the 1 because multiplying by 1 does not change the value. So this would be my most simplified option. Now, we're going to use the quotient of powers property to simplify these expressions. So I have 8 to the 3 minus 5, which actually gives me a negative 2. And I have y to the 5 minus 8, which equals y to the negative 3. When I expand these out, I have 3 eighths up top and 5 eighths on the bottom. And I would have 3 that cancel, leaving me with 2 eighths in the denominator. And because there's nothing in the numerator and 8 divided by 8 is 1, I could technically put a 1 as a placeholder. I'm going to do the same with the y's, and then we're going to find the pattern. So I have 5 y's, and I have 8 y's. And when I cancel, I'm left with, again, 3 y's in the denominator, and I need a 1 for a placeholder in the numerator. So notice the change. I go from having a negative numerator to a positive exponent in the denominator. Same here. I have a negative numerator, and I end up with a positive exponent in the denominator. When you have a negative exponent property, you can move it to the opposite position. So if it's a numerator, it becomes a denominator and positive. If it's a negative denominator, it becomes a numerator and positive. So 8 to the negative 2 would be the same as 1 over 8 to the positive 2. And 1 over y to the negative 3 would become just a y to the positive 3. Technically, it would be over 1 to represent the numerator, but again, anything divided by 1 is itself, so you don't need to write that. The rule for the negative exponent property would be a to the negative n, any number to the negative exponent, is equal to 1 over that same base to the same but positive exponent. And I can also write the reverse. 1 over a to the negative n equals just a to the positive n. Again, that would be over 1, but I don't need to write that because it doesn't change my value. We're going to look at this a few different ways. I have 6 to the negative 7 power. I can just rewrite that as a positive 7, but in the denominator. Here, I need to apply the product of powers property. So first, I'm going to add these. So y to the negative 5 plus 9. And that actually eliminates my negative right off the bat. I just have y to the 4th power. I could also write this in expanded form, and I would have to put these y's in the denominator, the 5 y's, and then the 9 y's would stay in the numerator. 6, 7, 8, 9. And when I go to cancel, I'm left with 4 y's in the numerator. So y to the 4th. On number 6, I'm going to use the quotient of powers property. So x negative 2 minus 3, because when I'm dividing with the same base, I can subtract my exponents, and that's going to give me x to the negative 5th. Now, x to the negative 5th would be an improper way of writing, so I have to move the x to the negative 5th to the denominator and write it over 1 for the placeholder, and then I can write x to the positive 5th. Finally, if I have 1 over x to the negative 10, I have to move it to the numerator, and 1 times x to the negative 10 would just be x, or x to the 10th would just be x to the 10th. So I don't need the 1 anymore. I move the denominator to the numerator to make it positive. Now, we're going to use the quotient of powers property again with our 3's. So we have 3 to the 4 over 3 to the 4, so I'm going to write 3 to the 4 minus 4. Well, 4 minus 4 is 0, so I end up with 3 to the 0. We're going to write this expression in expanded form to determine the 0 power property. I have 4 3's up top, and I have 4 3's on the bottom. And when I cancel, I have 1 and 1 and 1 and 1. Well, 1 times 1 times 1 times 1 is just equal to 1. So with the expanded version and with the quotient of powers property, that tells me that any number to a 0 power would cancel out and I would have 1. So any number to the 0 power would be equal to 1. If I have b to the negative 7th times 2b to the 7th, this 2 is the coefficient, so it's separate. And then b to the negative 7 plus 7, because I have product of powers property. So I have 2 times b to the negative 7 plus 7 would be b to the 0 power. I could rewrite this as 2 times 1, because any number or variable to the 0 power is 1, and that would just simplify to 2. So b to the negative 7th times 2b to the 7th is just 2. Again, I'm going to separate my coefficients. I have 10 divided by 2, and I'm going to use my quotient of power property and subtract. So I have x to the 3 minus negative 6. Yes, it's minus negative. And that's okay when I put that in my calculator. If I'm doing minus and negative, I'm doing the opposite of subtraction, so I'm actually adding them. 10 divided by 2 is 5, and then 3 minus negative 6 is 9. So I'd have 5x to the 9th power. This would also work because I'm going to move my 6 to the numerator to make it a positive 6, and I have x cubed and x to the 6th, which means I would have 9 x's. Now the next one has 4 different things I need to group. So I have my coefficients, my x's, my y's, and my z's. And I'm going to use colors to coordinate. So I have 18 over 9. I'm going to have x to the negative 2 minus 3. I'm going to have y to the 3 minus 1. And then I have z to the 0. Now I'm going to simplify. 18 divided by 9 is 2. X to the negative 2 minus 3 is negative 5. And I'm going to work with that later to make it proper. Y to the 3 minus 1 is just 2. And then z to the 0 is 1. Anything times 1 is itself. So really that times 1 is not needed. And I'm just going to rearrange. I need to bring this x to the negative 5 down to the denominator in order to make it positive. So I have 2 y squared in the numerator, and my x to the positive 5 would be in the denominator. So this would be my final answer. In this last one, there's a lot of different ways you could solve this, but I'm going to use my power-to-power property and distribute this negative 3. So first, I'm going to do 5 times negative 3, so I get x to the negative 15 over x to the negative 16. Now, because the negatives need to move to the opposite, I'm swapping, and this doesn't always happen, but because they're both negative, I'm swapping. So I'm going to have x to the positive 15 in the denominator and x to the positive 16 in the numerator. Again, there's a lot of different ways you could do this. You could have done quotient of powers property and subtracted, but I like to work with positives. Now, if I have 16 x's in the numerator, I'd have x to the 16 minus 15, and that just gives me 1x. I don't need to write the 1 in the numerator because, in the exponent, because it doesn't change the value. Now, Mr. Williams wrote the following expression on the board. Xander thinks the expression can be simplified to 1 because the 0 power property. Do you agree or disagree? Explain your reasoning. Now, you could move the negative to make it positive. Okay, so we're going to move this negative and make it positive. So we'd have x to the 8th in the numerator. Well, if we have 2x to the 8ths, we have x to the 8 plus 8. That equals x to the 16th, which doesn't equal 1. You could also use the quotient of powers property, x to the 8 minus negative 8, which also gives you x to the 16th. So Xander is thinking he can just subtract 8 because it's a negative 8, but when you subtract a negative, you're actually adding, right? When that subtraction and the negative symbol land next to each other, you're adding. Arlena is decorating the top of her graduation cap. The top of the cap is shaped like a rectangle with an area of 16 x cubed y to the 7th. The length of the cap is 4x y to the 8th. Write an expression that represents the width of the cap top. So we're writing an expression to represent the width. Area of a rectangle equals length times width. So if the area is 16 x cubed y to the 7th, I would have to divide that area by length, because I would divide the length to get it away from the width. Therefore, I would divide the length from the area, and that would equal the width. So this is my final answer. Okay, now if you were to simplify, we'd have 16 divided by 4, which is 4. I have 3 x's on top and 1 on the bottom, so I would have 2. And then y to the 7th over y to the 8th leaves me with 1 y in the denominator, or you'd get y to the negative 1, which has to move to the denominator to become positive. So that's actually our answer for our width. We didn't need to do that, but it's good to know that we can also solve. Finally, 3 students simplified the expression shown below. Circle the name of the student who wrote an equivalent expression. So I like to work with positives. So I'm going to use my understanding of positives or negative exponents to make them all positive. So I have 12R9 in the numerator. That can stay. But my S negative 8 needs to move to the bottom to become positive. Now my 3r to the negative 2s, the s can stay and the 3 can stay, but the r to the negative 2 needs to move to the top to become positive. So I've just rearranged and brought this s to the negative 8 down, and I've brought this r to the negative 2 up. Now that's still being multiplied times 2r to the 4th, and my s to the negative 3 needs to move to the top to become positive. And there's nothing left in the denominator, so I'm just going to put an over 1 for a placeholder. Now I group like terms. I have 2 times 12 in the numerator and 3 in the denominator. So 2 times 12 over 3. I have R9, R2, and R4 in the numerator. So I have R to the 9th plus 2 plus 4. I'm running out of room, so I'm going to move down and rewrite. So I have 12 times 2 over 3. I have R9 plus 2 plus 4. And then I have S cubed on top. And I still have S8 and one more S, so plus 1. Now when I simplify, 2 times 12 is 24. Divided by 3 is 8. And then I have 9 plus 2 plus 4 for my exponent of r, which ends up being r to the 15th. And I have 3 s's on top, and I have 9 s's on the bottom. And if I do 3 minus 9, I get negative 6. So I'm actually going to have s to the 6th in my denominator. I ran out of room there, but what I understand is that I have a denominator, so it can't be Lacey, and I have 4 s's, so it can't be Tamisha. So 8r to the 15th, s to the 6th in the denominator would be the correct answer, and that's Forrest. Now, you